This is CP1 Lesson 6, Properties of Midsegments. I hope you didn't have too many problems with your homework last night. I will be answering questions on that on Monday, October 21st. So just hold on to those questions. If you looked at the answer key and you can't figure out how to do a problem, we will deal with it when I get back. So for this lesson, by the end of this lesson, you will be able to determine angles and segment lengths within triangles using midsegment properties. You will also be able to determine angles and segment lengths within trapezoids using midsegment properties. And also, this lesson is due on Monday the 21st. Tomorrow, Wednesday, we have PSAT, and so about half the class will be missing. So those of you who are here, the ninth graders, you will have time to work on the assignment. So you shouldn't have any homework over the long MEA break. Okay, let's review the definition of a midsegment. A midsegment is a segment containing the midpoints of two sides of a triangle. Another word for it would be a median. No, that wouldn't be correct. We'll call it a midsegment. The segment connecting the midpoints of the two non-parallel sides of a trapezoid is also called the midsegment. So if I find the midpoints of my triangle sides, like right in here, and I draw that little segment in there, that's called a midsegment. If I find the midpoints of the two legs of my trapezoid, that's also called a midsegment. And there's a few properties that go with that. Okay, so we drew a triangle, and we drew in all the midsegments of the triangle. And what do we get here? If I draw in this midsegment, and this midsegment, and this one, and then I'm going to clone that, and I'm going to flip it. And what's true about this yellow triangle? It looks like it's congruent to that one, it's congruent to that one, and it's congruent to that one. Now this is any triangle. It looks like we've drawn a nice isosceles triangle here, but it doesn't matter. It could be a scalene triangle. So when I do this, when I draw in those midsegments, I create a fourth triangle. The three midsegments of a triangle divide the large triangle into four, not just triangles, four congruent triangles. And if the triangles are congruent, their corresponding parts are congruent. So I'm going to get some angles congruent and some segments congruent. We already knew these segments here were congruent because we joined the midpoints on all the sides. Actually, I better put different circles around these. So that's what midsegments will do. And you're going to get some angles here. What else is true? What's true about this segment and this segment? They're parallel. So we're going to have some congruent angles as well. Okay? Each midsegment of the triangle is parallel to the third side. If I draw this one, joining those two midpoints, that's parallel to this third side, the opposite side. And it's also interesting, this length here, what do you think what's true about that? This length and this length, there's a relationship there. It's 1/2 of that side. So if I want to mark it with tick marks and be consistent, this segment is congruent to this segment is congruent to this segment. So it's 1/2 of the length of the third side. So if I know some sides, I can find out a whole bunch of other sides. So if I wanted to take this segment, in fact, that's going to be half of this big one down here. And if you really look at it carefully, let me use the highlighter here. If I take this figure right here, this quadrilateral, I'm getting a parallelogram. Okay, so these segments have to be congruent. 1, 2, 3, 1, 2, 3. And this one is parallel to this one, so this is going to be equal to that one. Use some colors, draw in those parallelograms and triangles so you see what's happening. So let's see what we can find out here. I have a big triangle here. I know that this side is parallel to this side. So then this angle corresponds to that angle. Remember corresponding angles. They're in the same place. They kind of make that F. It's a little upside down. So A is congruent to that angle down here, which is 45 degrees. B, well, guess what? I also have parallel sides here. This one here is parallel to this one. So B corresponds to 95 degrees. Do you have to pull them apart to see them? Pull them apart. Okay, so that's 95. Do I have any other congruent angles? I'm sure I do. And how big is this one? If this is 40 degrees, how big is this one here? That's 40 degrees. And we can check, if I add up 40 and 45, does that give me A, which is 45 degrees? Sure it does. Now, how do you find C? Well, angles A, B, and C, angles, I better put my symbols in there, those form a straight line. I can't call them a linear pair because it's not a pair. They form a straight angle or a straight line. I like angle myself. So A plus B plus C has to equal 180. Well, A is 45, B is 95, and C has to equal up to 180. Or is there an easier way to do it? How about this? C and this one, 40, they have to be congruent. There's a lot of ways to see that. So I could add them all up from 180 and subtract and get the 40, or I could see that I have a parallelogram here, and I don't know if we know this yet, but opposite angles in a parallelogram are congruent. So that's equal to that. Now, segment E, that's this one right here, is half of the opposite side. So it's half of 16. So half of 16 would be 8. And now where's D? Got to find it. Okay, there's D, blue color. This segment is equal to this segment because the 6 centimeters is half of this whole side here. So D and 6 are the same. And I forgot to put my units in because we may be counting units sometime on your assessments. Let's get in the practice of putting them in. So I get a whole bunch of congruent triangles. I get all these angles congruent. I could have just used the fact that this triangle was congruent to that one, and then I can find the 40 degrees. They're all going to be 40, 45, and 95. Now let's look at the properties of the midsegment of a trapezoid. These segments are going to be congruent, and the side over here is going to be congruent to that one, and this is going to be parallel to the other two sides. The midsegment of the trapezoid is parallel to the bases, and we're just looking at this. We're drawing good pictures. This is not proof. And the length, well, what do you think is true about the length of that segment? It doesn't look like it's half of anything. You know what it ends up being? It's the average of the two bases. So it's B1 plus B2. You add the two bases up and divide them in half. So it's the average. And I'll think about how I could actually show to you that it really is the sum of those two bases divided in half. So let's find some missing information. Okay. What's true about all three lines here? They are parallel. So then that means A corresponds to the 60 degrees. B corresponds to the 70 degrees. And do you remember what's true about B and C? They have to add up to 180 degrees. So B and C have to add to 180. So the measure of angle C is going to be 110. And I like to put them in here. And the same is true with A and D. A is 60, and A plus D has to equal 180. So angle D is going to be 120. I know it looks like an isosceles trapezoid, but it is not. And To find E, it's the average of these two bases. So it's 10 plus 16 divided by 2. Some of you may think it's silly I'm writing that out, but if I don't write that out for you and you don't know that it's an average, you're going to wonder where I came up with the number. It's 26 over 2, which is 13. That's why I want you to write it out. You can come back in and you can look at your work and say, well, that's how I got 13, because later on you might not remember how you got that. And I believe that is all there is in this lesson. So let's go back and see what we learned. Whoops. We're going to determine the angles and segment lengths within triangles using mid-segment properties. When I draw a triangle and I draw the mid-segment here, this is going to be half of the base. And it's going to be parallel. If I draw in all the mid-segments, I'm going to have a whole bunch of congruent triangles, which means the corresponding angles have to be congruent. For trapezoids, if I drew the mid-segment on a trapezoid, like here, and if I draw a mid-segment here, this side is parallel to the two parallel sides, and this side is the average of the bases. So again, it's a lot of information to remember. So you need to be studying this every night so you can remember it. The night before the test is a little bit too late. It probably can be done, but I wouldn't recommend it. One last thing is, why is that mid-segment the average? So here's a little geometric diagram to help you see why the mid-segment is the average. I'm going to draw a trapezoid here, and then I'm going to clone it. And I'm going to move it over. I'm actually going to rotate this around. Okay, so I'm going to draw the mid-segment on this particular trapezoid. There it is. Now, I made a double of my trapezoid, and so I'm going to put this together here like this. And what's true about the mid-segment for my trapezoid, my other trapezoid, it's going to be the same. So I'm going to put this in here. And look at that. I actually was going to make it harder than it is. What's true about the length of this, of two mid-segments? Two mid-segments together equals, if this is base 1 and this is base 2, then this is base 2 and this is base 1. They add up to base 1 plus base 2. But I don't want 2. I only want 1. So I'm going to divide by 2, and there it is. It's B1 plus B2 divided in half. So that's why it's an average. You don't have to remember how to prove it, but I did want you to see it so you would actually believe that it was half of the sum of the two bases. That part you do have to remember. So good luck on this assignment. It's due on Monday the 21st, and on Monday the 21st, we will be working on pulling all the pieces together. I don't know that we're going to go on because it is a short period. Remember, Monday is an early release day. So have a great weekend, and I'll see you soon.